houses which have oil-based heating, and this is more applicable to for remote managing that. Let's say if I'm not in the house and I don't want to be there to bleed the air and fill up oil again. So that was the starting point. Another thing is we wanted also to get some more use of data outside this project, so that we gather all the time series data of how much oil is being consumed, if it is being stolen, if it is going at a bigger rate, more than normal, how much of oil we are using, how much of money we are paying. All that data we can collect once we have all the data in place. Right. So what we managed to, I'll cover how did we do that and what we managed to do. So it's a very basic sensors. To sense the oil, we used the ultrasound. So sound is the most safest because it's a very highly flammable liquid, so better not put electronics near to that. So sound will just measure the distance between the top and whatever the oil level is, and it transmits. So using a radio transmitter. Now, because it has to be outside the house, remote location, it has to be battery operated. So we need to also see how long will it last for the battery. The next was the receiver component. The same thing, it receives. It does a lot of things. We have to check for the alert events. If the oil is at an alert level, it will send an email, mobile SMS notification. So we are able to send an email notification. I didn't configure my mobile for that. It creates hourly file. It creates. So that is what we are able to generate. We collect all the time series data every hour. So basically, we record every minute. So in 1 hour, we'll come to the stats. So every hour we make one file, and as we make the file, we send it to the cloud. So we store all the cloud data in the cloud, so that our Raspberry Pi does not be flooded with data and it won't eventually crash. And there's a background job which continuously syncs all these time series data to the cloud. So that happens. And then deletes the file, because once it is in the cloud, we don't need it here. So that is the second component. And then we had server side. Now, all this data is going to the web. Now we need some way to represent what makes sense out of it. So, that's with the DNS. So that's the DNS that's working. If you can go to iot.beehive.holiday, you see the dashboard. It's all mock data there because we didn't yet do the analytics or parsing of the time series data. We just put it there so that was not the scope of this project anyways. So it's a placeholder where we can do analysis and present in the dashboard. But the dashboard, the hosting of all that, DNS mapping, all of that thing is done. This is the most interesting, I think, that geeks here will like. So in one day we collect, if we are recording every minute, what is the time and how much is the meter reading. We collect 14.4 KB of data in a day. So it's pretty easy so it's very affordable to store the whole data in the cloud. That's one. Now, we were using Arduino Uno, okay? Now, we measured how much of power juice it is taking. It was taking 126 milliamp hours. We put some delay, it doesn't look like it made any difference. So even if you were running it on 18650, that big battery, it would only run for 3.2 days, so it's not practical. So we need to work on this sensor, and so if that is the number, so that transmitter is not workable unless you make it more efficient. So it should at least last for 6 months for that to be practical. So that is what we found. We'll keep working on the. I think that's all for. Let's not go any further.
Yeah. Well, you wrote it.
Over the course of the weekend, trying to make bubble machines. We made a few different prototypes. Myself, Paul, Robert begrudgingly gave lots of advice, but very little help. We had other people help and come give lots of suggestions throughout the day. So we have it set up in the kitchen. It's a terrible demo because what we found last night, we had lots of fun with it, and we splashed lots of bubble mixture everywhere. that it's all got inside the motor and now it's all kind of jammed up and kind of not really working. But in terms of, yeah, we managed to blow in large bubbles. There's plenty up on the Science Hack Day Twitter account. There's a few videos going around of the size of the bubbles we did. Paul did some experimentation with making our own bubble mixture with washing liquid and sugar, and that gave us this really thick, viscous kind of one that we create really long bubbles, but they didn't really kind of dripped everywhere and kind of made also another mess outside. But yeah, interesting project. We'll probably try and build some more bubble machines for EMF Camp or for Dublin Maker maybe towards during the summer. So yeah, at the end of the day, you can come out and check it in the kitchen if you want to see it kind of half working, and we'll give a demo there. Thanks.
Team, actually without idea, we didn't, let's say, fancy any other idea, so we was with a Let's Try and a Raspberry Pi, and we came with the idea, so let's build a kind of a game using whatever we had. So we end up doing something like this. We just wrote the Let's Try on the board, and then the weekend was just more or less coding, and we built some games here. So we start with the idea of like, let's do a Pong, let's do a Snake, let's do a Connect 4 or whatever. So we end up finish the Connect 4, and because we have the LEDs on both sides, we came with the idea to do the battleship. So hopefully it works. So I will show first the Connect 4. If everything is continuous in the perfect size, and we have the energy.
Oh.
So you can go right, and when I press down, the things fall. So you can play like this. I just so I will just win for red here or whatever. So red win. And then we build the battleship. The battleship, the idea is we put some dot, the ship is just a dot, and we create a handle, so it can be up to 50 or whatever. And then you can navigate again the thing, and every time when I press, so blue is water, so then I found the ship here. And I have kind of limited lives, so we just can play around and things. So kind of one way to play. And yeah, and then here you can see how many lives you have and how many times you fire. And the last one that we create, I hope I don't need to explain what is. Yeah, you can see some. Anyway, yeah, that's it. Thank you.
Sometimes, I love this when it happens, so sometimes you turn up with a plan and on the day something else happens, which is actually more fun than what you planned to do. Today wasn't one of those days. But it almost was. So just to recap, 2 years ago, Killian, Sam, myself and a few other people did a Geiger counter radio activity, and I actually thought we'd be coming here today to win basically the same project we did last time award. What we did instead was learn about being over ambitious. So it started off with the idea of, hey, there's an actual very simple radiation detector circuit that's available on the web, it was published in a magazine, loads of people have built it. Let's just build that, and that's obviously going to be far too easy and there are going to be lots of people helping. So let's go further than that. Let's build a printed circuit board with a CNC machine that we've never used before, as you can tell if you actually have a look at what we made, and 3D print an enclosure for it. So we actually end up at the end of 24 or 48 hours, 36 hours, an actual working product in your hands. So things started to unravel when we discovered that the circuit didn't actually work. You needed a printed circuit board first that had good grounding to be able to prove whether that circuit works or not. Which meant that the people who were trying to design a printed circuit board couldn't start designing a printed circuit board because they didn't actually have a schematic to actually work from that actually worked. And the people who were designing the enclosure, you see how we kind of segregated everything nicely. You know, there's electronics, there's software, no, we've got to that, PCB and mechanics, and individual people working on them. But it was very serialised. So people were sat there going, yeah, well, got no PCB design, so I can't make an enclosure in the PCB design. Going, do we have a circuit that works? And we're going, no. And then we kind of sort of went, well, let's pretend this circuit will work. Let's go off and design a PCB. And was it David? Yeah, David went off and used EagleCAD and laid out the board. And then we went to the next thing of using this little machine down there in the corner to cut out our printed circuit board. Loads of people have one of these machines on the web. Everybody's done it before. But actually, there's a million configuration options required to set your set the machine up with your data file before it will successfully print, which we were unaware of when we started. So this weekend, in summary, was we have a circuit. It's actually really good at detecting when people turn on angle grinders. I think if you go to the last page, there's yeah, see that? All those spikes, they're not random radiation events. They're magnetic events from an angle grinder 30 meters away. So that's pretty good for that. Maybe we should publish we did get to an enclosure design, and I really like the way the switch is submerged in there. It fits really well. Pity there's no electronics. But that will come. So yeah. So summary of this weekend's hackathon is be careful what you plan for. Thanks, Matt. Thank you.
We started on. What is the day we started?
Oh, I think Sage is going anyway.
We started on Saturday morning with the idea of making a duck green. We can say this duck, we just don't really want. So, over the course of working, what happened was we had all these sorts of ideas of using cams and this particular motor here, and we even laser cut out the cam, but it turns out it doesn't have enough torque. Yep. Enough crack. Then we tried some other ideas, but again we ran into sort of torque problems. But eventually we came across one that actually worked. The racking pinion system, and this was we tried some setups for the laser cutting, what this was sitting in.
So just simple laser cut gear, some laser cut bar, laser cut racks, spin the gear, it opens and closes. The basic mechanism works. We printed it with as small piece of wood as we could to try it. You can't make that in cardboard.
One thing we did learn though over the course of the weekend from the medics, Phil and Shu and others, we basically came to the conclusion the best thing to build was a really cheap ventilator using Arduino. The name of the motor is NEMA 17, which is really cheap.
It's the same one as used in 3D printers, so they're sold by the million now.
They were like 10 or something, weren't they?
Less than.
Yeah.
That's about £3.
So all the parts together, if you came to laser cutting, everything still came to sort of, the bags are about a tenner because they're used everywhere all the time, they're disposable. So all the parts together is under 20 quid sort of pricing. Do you have a description of how it works?
Yeah, so we built this setup here anyway just to sit the BVM, this is a BVM, so to sit that in there. The problem we had was, well, we built basically a linear actuator setup here, but the problem was we couldn't get enough torque for it to compress. So we're going to keep working on the design of that, and we have some bearings here. We're just going to have to move those around just to stabilise it a little bit. And I guess Besides that, for the time being, we were going to incorporate some sensors as well for capnography, for picking up the amount of CO2 and things like that, and pulse oximetry and things like that. We
Also, just air pressure, so you don't
Yeah.
pop people's lungs, and air flow, so you can see how much air they've had.
Yeah.
You wouldn't want your duck exploding.
So what we found as well with the latest kind of stuff that's coming out as regards corona, and that they're recommending not to have non-invasive ventilation. So this actually is not really implementable unless you intubate someone, unless you have a room with negative pressure, that because they're finding this sort of ventilation will actually disperse the virus. So that's how a lot of healthcare workers are picking it up at the moment. So unless you have you've got negative pressure in the room with that, it's not really viable at the moment. It's contraindicated. Is there anything else you want to say?
No, it's fair. Do you want to put it up here? Did we take some dinner?
No, public trouble. It's not quite strong enough to squeeze the bag, this is quite stiff. That's why we want an air pressure sensor.
We think the motor is strong enough. Maybe 1 or 2 changes in gears and also some reducing the friction on the actual system should be okay. The principle's proved. We're probably a few hours away from smoothly running, but also maybe a few hours away from adding a few extra sensors just for safety reasons. So, great fun. Learned lots.
We're hoping to put all the latest up design online, so once we've got one that works, so anybody with a laser cutter can download it, hit print, buy a cheap motor online, Arduino, it's all standard parts.
The code's on GitHub.
That's it.
Okay, so I think my team and Robert here. So that. So yes, our team. So we made. Yes, we're going to explain all of this. This will make sense with some values of sense. So yeah, this is the team. Owen, Luca, May was here yesterday, did a lot of work as well, and I'm Declan. Okay, so this is the robot. Did it move?
Yeah.
So the parts. I bought a cheap Arduino robot kit from China a few years ago, and I took it out of the box, and there were no instructions. And I tinkered with it for a while, and then I threw it away in the box. So eventually I gave up this year and actually looked for an instruction manual. And there were plenty of them, and they were all terrible. So I screwed some of the bits onto the box, realised that in the meantime I lost some of the bits, so I decided that I needed some help. So yes, we formed a team around making a robotic hedgehog. No particular reason, the hedgehog just, you know, I could have just made a car, I made a hedgehog instead. So yes, we kind of, the first thing was, most of the morning was taking apart the bits I got wrong and trying to reassemble. We eventually did get it to work. So yeah, there's the components. Is this demo?
It's a demo.
Okay, let's do the demo.
We have a very complicated on switch, which is the most reliable part. Do you want to talk about what we do?
So yeah, so it's moving. It has a, is it a time of flight sensor or something? Or what's
It's one of those ultrasonic distance sensors.
so that's,
Yeah, it's supposed to do it.
yeah, so then we have, yeah, so there's kind of the innards. Oh, it's still going. We'll just let it go, just someone watch out in case it gets away. So, yeah, basically we wanted to make the hedgehog. We were looking at different ways. At one point we were going to use matchsticks, and then we realised there was lots of foam, and yeah, so Maeve did a lot of work with the foam and also, you know, with the wiring. So we tried a few things with different radios and different ways to control it. So it almost works with a joystick. And it will work with the joystick soon, but at the moment it's completely autonomous, so it's just decided not to go anywhere. But it gets bit shy, you know, all of that AI stuff we put into the Arduino is really working. And then someone came around yesterday and said that they wanted a duck. Oh, is the back on?
Oh, it's very complicated, lads.
Yeah. So yeah, the back, basically we wanted a duck and we were wondering how would we include a duck. So we were going to put wheels on the duck. And then we thought, let's put the duck in a cart because that's funnier. And then someone said, let's put lights in the cart. And then to put lights, we needed a breadboard, and then we needed a power supply and another Arduino. So then it's like, yeah, let's just make a big cart. And then just for mounting reasons, it was easier to put the duck on a stand. So that's the duck poking wheel. So yeah, I think we've got a project here that at the moment would be great. Well, it's going into, as I've started to call it, the TOG collection. And we'll bring it out to science outreach events. The kit itself is terrible. The just no instructions. Some of the soldering is really difficult to do, and you know, it's just it works just about, but I wouldn't recommend a specific kit. But yes, we have a robotic hedgehog. Is that the GitHub link? Yes. So yeah, the code's up on GitHub. We're working on a few things, and obviously anyone's welcome to contribute to it and come back here at Electronics Night if you want to try your code out on the hedgehog. I think the trailer might have to go. It's not practical for reversing. So yes. Anything else anyone wants to add? Or is that,
That's all the important parts?
yes. So thank you.
So thanks very much.
We aim, this is Chris and myself, and sometimes we aim to be just on this side of impossible when we're in the design project, and occasionally we'll end up on the other side. And I'll let you try to decide where we ended up. But knowing what I know about physics and optics and things like that, which I enjoy, you can tell from the spectrum, you can tell a bit about the substance. And so when I heard that there's labs around that are testing for this virus, I thought, well, I wonder whether you could test for the virus with optics. And Duncan harvested, I think, a whole box load of optics parts that would probably cost somebody 10,000 euro at some point or whatever. So I certainly had the optics to work with. And I even found a lot of really good resources online for what people have done with biology and optics. And some of it even involves ordinary devices like CDs, DVDs, Blu-rays. And one of them used a device called an HD DVD. Unfortunately, the one that does the Raman scattering, which is one of the things I was trying to maybe simulate, required you to coat your DVD or HD DVD with gold, and I wasn't able to do that. And well, I really do enjoy this wedding ring anyway. So we thought, okay, so what else can we do? And it turns out you can exfoliate most cheap DVDs by just sticking duct tape to it and just pulling it off. So I've done that. You know, you can see here the Norton OS 9 antivirus disc. I'm used for it. You can take off the layer, and then it becomes a really nice diffraction grating. And you can break the light into components. And there's an example. The first page was an example. And here's the device. Now, I've seen some people make a sextant out of a CD, so they could make optic devices out of CDs. In this case, what we have from that projector, we have these really nice dichroic mirrors, which, depending on the angle you look through them, they can actually cut off parts of the spectrum really sharply. And then one of the things I thought, well, maybe it's a little bit of a stretch goal to decide we can decipher the difference between two different viruses, or even that there is a virus, or anything. Can we detect whether it's coronavir or vitamin D in water or some other yellow liquid? And one of the things I was wondering is whether you could use fluorescence. And if you see on the right side there, I am shining a ultraviolet kind of black light laser,
at the coronavirus on the right side there, and you see in the spectrum, on the top there, you'll see a little purple spectrum. That's the spectrum of laser. Laser spectrums are kind of boring because they're mostly just one color. But when the spectrum, when the UV light hits the beer fluoresces, and we're actually getting a spectrum of the fluorescence of that. And with this device, I don't know if you can see colors coming off of the DVD just from the slit lamp here. And part of the idea of this is you could put a liquid that fluoresces, turn off the slit lamp, and cause that to fluoresce. And then you can look at a spectrum of the fluorescence of whatever it is you're looking at. So you could possibly do absorption spectrum from the slit lamp, and the spectrum of the fluorescence. But it turns out there's another way of doing kind of a high level thing, is you can aim, if you go back, did I slide? Go back one page. There's an app that you can get, there's already an app, that you can just strap this DVD or a diffraction gradient straight to the front of your phone camera, and you can go into the app and it can detect atoms of different light spectrum and stuff like that. And here it thinks it detected neon, and I was looking at a neon bulb in the kitchen there on the cooker, little neon bulb on the cooker. The app is open source. It's made in Singapore. I think I have a link to it on my webpage, opensourcemechanic.com, and I'll make sure that it's in the upload thing that I uploaded to YouTube. Go to the next page. But overall, we had another project here, and a couple of the other guys worked on that project. I think they went out to form a band or something. Yeah. So anyway, and that's great. That's fantastic. That's what this is all about. Making people form a band, whatever. And, but their project was to detect fake science. And on the right side here, you see this is fake science for the Middle Ages. You put a bird beak on your face. You put some potpourri in there, it'll protect you from the black plague. And the left, this is fake science too. If you go to the doctor, he shows you this and he says, I'm going to see if you have coronavirus. Find another doctor. So that's it.
Patients. We enjoyed grinding and cutting and drilling. So this is an injection machine for the plastic, and well, basically what you have to do is take the shredded plastic, put it into a hopper here. This is that are heating elements, so it heats the plastic to molten temperature, and then you just press this toggle and it injects all the melted plastic into the mold, whatever you're gonna attach it there. And yep, here's electronic part to set up the temperature. Because
that's one of the few parts that actually works. So they're just like invert PADs, and there's solid-state relay in there that switches the heat elements on and off. There's two thermostors that measure the temperature. And what you have to do when you extrude the plastic is that the lower nozzle just has to be at a slightly higher temperature, maybe 10-15 degrees higher, because you just want to give it this extra boost if you inject the plastic into the mold. And the upper three, they run on the same temperature, so that's why there's only two thermostors here and two settings there. Right now they're set to like 30 degrees and 27 degrees because we just have a piece of wood in here instead of a steel bar.
you don't want to burn anything.
Yeah, exactly. So
basically that's pretty it.
that's the thing. Our welding skills are terrible, but thanks to Christopher, who yesterday helped us out until like way past midnight. David is there, and we did our first baby steps in welding, and I then said I'd rather stop after I welded the second hole into our so I said, okay, I'm not continuing to do that. So everything is a bit crooked. It does work, like it doesn't get stuck at least. It also doesn't extrude any plastic.
At the moment,
So
but
the-
once when I get the steel bar,
Yeah, so the idea
operational,
is that you put a threading down here and then you can just use like normal plumber's supply things to like put the mold.
use it as a nozzle.
Exactly.
So as to the nozzle you're gonna attach to your mold and then inject the plastic inside. Yeah, maybe you want to another project which we do
Yeah.
like.
So it's like I was just saying. Also, when you do a temperature control thing, so the circuit, the PIDs and the heating elements here they're rated until 1,500 degrees Celsius. A lot of people use it for home brewing. I don't know if any of you guys here use it for home brewing. However, the thermoses are only rated to 400 degrees, so you burn out your temperature sensing device before you actually burn out the thing that drives the power to the temperature. The first time I switched them on just to see if I wired everything correctly and I don't get electrocuted when touching the sensors or the enclosure. I was super happy that it was heating up, but the temperature didn't change. And it was heating, and all of a sudden it's like a bit of smoke came out from the side. So I just realized I had to attach the furnaces actually to the heating elements, and the furnaces were reading room temperature. And the heating element was just getting full power for like 30 seconds, and I don't know how hot it got, but it was quite hot. So don't do that. Always make sure you actually put your sensor to where you want to measure something, especially when it gets very hot. So that's this guy. And then, so I scavenged this kind of like server power supply thing from the electronics keeping it work, and it was really nice form factor. And it came with two 1.7 amp fans in the back. So I was like, oh, that's great. We can use them to just cool the whole thing in case it gets hot. But it turns out it doesn't really get hot. And there's a lot of like passive cooling elements in there. So I was like, okay, so what can we also do with the fans? Also, they're super loud. So when we get the plastic, for example, from our from your collection point that you have for us, we then have to wash the plastic, or you do it before we prefer that, and then we need to dry the plastic. So we have a plastic drying crate where we just attach
Those loud fans.
fans onto the side, and also again, don't try to stop a fan with your finger. That chops off the part of your finger. So now you can dry your plastic. You can drip off through the holes there at the bottom. And I think if you get a few more of those fans, we could actually make a hoverboard. But that's maybe for next year.
That's it.